All right. So somehow it's already the back half of week 7. The quarter goes by very quickly. What we're going to do today is I'm going to teach you some stuff about graphics. The sort of next unit of material that we're going to be doing is drawing and painting shapes and images and stuff on the screen. We're going to basically learn how to make like really crappy games and animations and stuff. That's the plan, and then that's what homework, 6 will be. You'll do a little game. I'm going to have you make the snake game. You ever play the snake where the snake moves around and eats the stuff and the snake gets longer? I'm going to have you do that for your homework 6. That's the plan. Yeah, let me just get on into it then. 2D graphics and animation. Here we go. I don't think I have any announcements or anything, so let's get started. If you want to do graphics and animation, I guess I should say there's a lot of ways that you could do that. Mostly, if you're going to make a game, like a real, actual game, you would use some very heavyweight library or coding environment to help you. Have you guys heard of any game building environments? Yeah, what? Unity, yeah. People have heard of these engines, like Unreal Engine and stuff, and yeah, Unity might be the number one. So, like, if you were going to actually make a game that you wanted to produce and sell and make money and, you know, real game, you would probably want to learn something like that because it's more powerful and it's better and it helps you do a whole bunch of stuff. Everything from drawing graphics to playing audio to little AI algorithms for computer characters to networking stuff to user input and joystick and mouse kind of stuff, like just all of it. And a lot of these systems are meant to be somewhat platform neutral. Like if you learn how to do Unity, they have their own editor. You don't even use Android Studio, you use their editor. And then when you're done, when you've built your little project, you say like, produce Android app, go, and it makes one. And then you can say produce iPhone app, go, and the same code basically makes both. You know what I mean? Like you can write the game once and it'll deploy to different devices and stuff. And so that's like if you're legit making a real game, you do stuff like that. But I'm not really, this is not like a make a game course, you know. I'm interested in sort of more modest ambition. Like I just want to have an app where I draw some shapes and maybe I have a ball that bounces around or something. And I guess you could use Unity for that, but I think that'd be overkill. So I don't think it would make any sense today for us to like do a day on Unity or something. But if you're going to do it yourself, what you do to draw custom graphics is you have to make your own class that extends a superclass called View. Now, you haven't really thought about a class called View before, but View is this superclass of all the widgets that you have used, like button and text edit and all that stuff. Those are all subclasses of a superclass named View. So a view is just any sort of on-screen gizmo that would be, you could declare a view in a layout XML file or you know, refer to one in a Kotlin code or something like that. So if you want to draw shapes and things, you make your own subclass of View. So let me show you a little bit about how that looks. You write a class. This is like a template here. You write a class, you make your own file, like whatever.kt. You declare your class, and this syntax looks a little bit weird here, but you know, here's you're declaring that I have a class, and here's part where you're saying it's a subclass of View. In Java, you'd say like extends View. In Kotlin, much as like C++ and some other languages, you indicate inheritance with a colon operator. This part looks a little weird, these parenthesis sets. Basically, this is the set of constructor parameters. You know, in a language like Java, if you have a class myView extends View, you do something like that. This is Java. And then if the View class has a constructor, then usually that means that your subclass has to call that constructor. So you'd write something like, you know, constructor. You'd say public myView. And maybe if your thing takes a foo called f, maybe the superclass constructor you do something like that, and you initialize, this is like stuff you do in Java, right? Constructor is what gets called when the object gets created. When you say like new my view, it calls it constructor, right? So in Kotlin, we sort of rearrange this a little bit. Like if you meticulously read my Kotlin slides from a month ago, you would have seen this a little bit. But you sort of start from the same look, but instead of saying extends view, you say colon view, and you take these parameters from here, you cut them and paste them here, and then you take what you pass up to the super and you put those here, and then you just don't write the constructor. And I guess parameters are written as like name colon type. So like you just sort of cut and paste and move the pieces around, and that's how Kotlin says the same thing. And I think this looks a little bit weird, but what it means is that you don't explicitly have to write out constructors as often. And instead they are sort of implicitly described by these parenthesized thingies here, So anyway, you don't have to think too much about that, but I just don't like showing you code where it's like, what does that even mean? What does that combination of symbols mean in this language? It's just an inheritance thing. So the part that really matters is you have to write a particular method named onDraw. And this method is called by Android whenever it redraws the screen. It's going to ask your view how to draw itself. And that method is passed a parameter of type canvas, and a canvas is a basically like a drawing pen that you can say, I want to draw an oval or fill a rectangle or draw a line, and it has these various methods that you can use to make shapes and colors and images and stuff. So you basically just want to follow this template where you first say super on draw, and then you give commands to the canvas of what you want to draw. So that's the plan. It's pretty similar to most graphical systems where 0, 0 is the top left coordinate of your view, and then the x goes to the right and the y goes down. That's pretty common. And the coordinates are specified as pixels in the type float. It should be int because that's the right type, but they use float, which is basically like a double. I don't know why, but that's what they do. Yeah.
Is this somewhat similar to the 106B assignment you gave last quarter regarding fractals?
So it is sort of, what you'll see some similarities between this and graphics from 106A and 106B. Now, I believe you haven't taken 106A here at Stanford, but some people have. And in that class, you make these G rectangle shape object thingies and you put them on the screen. There's going to be something similar to that we can do here. There's also, every language and different libraries have their own ways of describing graphics. And some of them have more of a procedural style where you say, draw a line, draw a rectangle. And other ones have more of an object-oriented style where you say, new line, new rectangle, and then those objects like appear on the screen somehow. This model is more procedural, where this canvas object has a bunch of methods you can call to draw things. I'll show you some of those methods now. Wait, where is it? Where is it? Here. Here's some of the methods that canvas has. I'm not going to spend a lot of time on all of these methods, but we can refer back to this in a minute when we want to draw something specific. Like you can say, I want to draw a circle, I want to draw a line, I want to draw an oval. These kind of names and this set of things should look sort of familiar to something that you've seen before, I would guess. Okay, cool, shapes, rectangles, ovals, fine, right? Pretty simple. The one thing here that might be a little confusing is that like some of these have two different versions. Like there's one that says rectf. That's because like sometimes you pass in the xy coordinates as a rectangle object, and sometimes you just pass them all in as individual ints or floats or whatever. But that's not very hard to navigate. The other thing is that you sometimes pass this thing called a paint. I'm going to talk about that in a minute, but that's basically like what color do you want it to be. If you want it to be a red rectangle, you pass a paint object that stores the red color in it. I'll show you that in a minute. That's mostly the set of stuff that's there. I didn't list everything, but I listed the ones that I thought you might really want to use. Now, if I back up again for a second, if we write that view class, let's talk about like how does that integrate with our app? Well, you would still have an activity. Every app has some sort of activity, but inside of that activity, in your layout, you would declare a tag for your view that you have created. And so you write, you know how you can say like bracket button and then you get a button, or bracket image view and then you get an image view. Well, if you make a class called Marty view, you can say bracket Marty view, although you're supposed to write out the like whole package name of the class, and then it uses all the same parameters that you're used to, like width and height and top to top and left to right and all that constraint layout stuff. So let me show you a little bit of this real quick. I have a project here. I've already, oops, wait, I'm in the wrong project. Hold on. Close. Oops. It's called Bouncing Ball. This is a real exciting project we're going to write today. So if you make a file called whatever view, like Bouncing Ball view, and then it extends view, like we said, I got a couple like ints here. I'm going to make a bouncing ball, but don't worry about those. Those are just for later. But you make an onDraw function, and the first thing you do is call super.onDraw. And then I just wrote this line of code that says if the canvas is null, because it's a question mark. If it's null, I said return. That way in the rest of the code, I don't have to use question marks or exclamation marks to refer to it, But now down here, you can draw whatever you want. So you could say like canvas dot draw line, and then it takes, if I just look back at the slide here, it takes the 2 coordinates and what kind of paint you want, So you just start writing these commands in here, and that's what it'll look like when this thing draws itself. So I'll do that in a minute. But in terms of like getting this thing to appear on the screen at all, you need to open up the layout for your activity. Now, here you'd say like bouncing ball view, but you write out the whole package of like your thing that you're working on, So that's it. You just declare it. If you want, you can give it an ID. You can give it a width and a height. It basically behaves the same as any other type of thing. It's just as if you had said, button. Except instead of button, you're saying bouncing ball view. So there it is. So that's how to get started here. Any questions so far? Does that make sense? Yeah.
How was there already a ball on the...
Oh, yeah. I was sort of dodging that. I noticed that here. Yeah, why is there's like a red ball here? I think that's because earlier I was coding it and I put a red ball in it. And then it like remembers that it's kind of a ghostly after image of the code that used to be there before class when I was playing with this. Like there is no bouncing ball being drawn here.
Okay.
So like I think what it's trying to do is like when you declare a widget here that it doesn't know very much about, like if you declare a button, it knows how to like draw a button. This is like a preview, right? But I think what happens is it doesn't really know how to draw a bouncing ball view. So it normally would just have gray here or maybe a question mark, I think. And if you run the app, it like sneaky takes a picture of it and says, oh, that's what a bouncing ball view looks like. And then the next time you're editing the code, it's like, here, it looks like this. But now it doesn't because I deleted the, you know what I mean? It's stale. So don't worry about that. But anyway, you make a class that extends view. You make an XML tag to put it on the screen. Right now, I've got this thing taking up the whole screen because I said the width should match the parent and the height should match the parent. But I hope you understand that like you don't have to do that, right? Like you could do something like down below this you could make a button, and the button could be some sort of OK button. Text equals OK, and that button could be, bottom to bottom of the parent, left to left of parent, right to right of parent. And then like this guy here, this bouncing ball view, he doesn't have to take up the whole screen. There could be like buttons and other widgets like around him, like maybe his top is to the top of parent, maybe his left is to the left of parent, maybe his right is to the right of parent, but maybe his bottom is to the top of the button I just made here. His ID is OK button, so maybe this guy's bottom's to the top of OK button. There, did I do that right? Wait. The bottom of me, there, did I do that right? Yeah, so do you see like the bouncing ball view is taking up all of the screen except for I'm just saying you could make this thing whatever size you need it to be for your app. Like, I don't want you to think that this view somehow is the whole activity. It's like a widget, but I'm drawing the widget's appearance exactly the way I want, and it's basically serving as a drawing canvas for me, okay? So that's kind of us getting started here. These are some of the methods you can use, and before I can go much further, I need to talk about this paint stuff because I need a paint in order to draw anything. So I'll show you that here. Now that's the next slide. So if you want to paint, you make an object of type paint, and then you can set its alpha, red, green, blue components. Alpha means opacity, transparency. So like if you specify these 4 components, they each from 0 to 255. So like, you guys seen this before with like computer colors. Like if you give a high number for that, it means you have a lot of that color, and if you give a low number for that, you don't have a lot of that color. So like if you want the color purple, you say val purple equals paint, and then purple dot set argb. The alpha, I want 255 because I want it to be a fully opaque, visible color. I don't want it to be semi-transparent. And then for purple, you'd say like full redness, no greenness, and full blueness. And then if you want to draw something in that color, maybe you'd say like canvas dot draw oval, and you'd say like a rectangular area of 1010 to 300 using that purple color. Oh, and it's mad because these coordinates for this stupid thing have to be specified in float, which is like double. So you could say like 10.0 f or 10 f, whatever. So now I'm drawing an oval. If I run this thing, I think I could run this. I think we've got enough code that I can already run it. So let me just see. I mean, if this behaves properly, what I'm going to get is just a stupid purple-looking oval that doesn't do anything. It doesn't move. So you're not supposed to be impressed yet. You have to hold your applause for the moment. But let's see. There. Yay. A purple circle. So, I mean, you might be surprised, like, oh, okay, well, it's at 1010 and its size is 300, or I guess its bottom right is 300. Like, maybe it wasn't obvious, like, how big is 300 pixels on the screen? Is 300 pixels most of the screen, or is it a small fraction of the screen? And you don't know, right? Like, different number of phones have different number of pixels. So sometimes, I mean, in homework 4, maybe you were thinking about, like, I want half the width or half the height for these images or something. Like, you might want to use similar logic here to ask for the screen size and say screen size over 2, screen size over 4, and then make your size of your shape based on that so that the appearance of the thing looks the same on everybody's phone. But I didn't do that here. I just made up some numbers. But anyway, I'm drawing an oval. And it's purple. So that's kind of our very first start. Okay. One thing, if you look at the code here, it's got this in yellow as like a warning, and it says, hey, you should avoid object allocation during drawing and layout. And it says pre-allocate and reuse instead. And what that means in English is like this drawing process, if you're doing a lot of complicated work in this function, that could make your painting code be slow. And most people who are making games and animations and stuff, they want everything to be really fast, right? So they're concerned about possible performance issues. And like this method could get called a lot of different times, like kind of every time the screen repaints itself, it calls this. So what they really want you to do is like come up here and like save this color, save it away somewhere, and maybe like, when you only create it once, you're not going to allocate as many like paint objects every single time the thing redraws itself. Same thing for this rectangle. This creates a rectangle object, so you could technically save that somewhere. But I'm not going to do that for every single little object. But that's why that thing is like highlighting it in yellow. It's just telling me not to allocate objects every time I paint the screen. Anyway, so if you're making paints, here are some of the things you can do with a paint. Once you've created it, you can set its color and its transparency. You can use paint to do things with text. I'll show you that later. But like there's some of the members that a paint object has. I don't have all these memorized. I just type a dot and see all the stuff that pops up. If I'm looking for something, I just look at all the different options and see what they have. But mostly I think of paint as colors, you know. And if you're not good at RGB, which I'm not, I don't think I'm that great at RGB, so here are some colors that are common, and there are the RGB values that produce those colors. Or I think if you Google for like RGB color picker, you could see a nice palette, and you could say, I want that, and then it'll tell you the numbers for the color that you want, right? So there you go. So like I guess if you want this lovely, is that a pink or a bubble gum or a purple or something, you can say, what was it again? 254, 121, 209, 121, wait, I did it wrong. There, or 255 alpha, there. So if I set that to be the color, instead of being a pure purple, it'll be more of a pinkish purple, whatever, right? So you set the color, you figure out the colors you want. Okay. See, we don't need Unity. We could draw a pink rectangle and pink circle and stuff. So if you want to make fonts and text, that's called a typeface. And there's different fonts that come on every device. You know, like, I don't know if you've ever dealt with fonts when you've coded before, but like, you know the fonts when you write documents, like maybe you'll say Times New Roman or Arial or Helvetica or Courier, right? But of course, the problem is you don't know what fonts are on a given person's computer or phone. So usually when you describe fonts, you describe them more generally, and you say, well, I want a font that has serifs, which are like swooshes at the end of the letters, right? You know, like the like a letter F without serifs looks like that, and a letter F with serifs like has a little like pretty thingy at the bottom, right? And a little swooshy circle, you know, like that kind of stuff. It looks like fancy schmancy, like, you know what I'm talking about. So, and then sometimes you want a mono-space font that looks like a typewriter, evenly spaced letters type of font and stuff like that. So usually you use these constants to describe what fonts that you want. If you really want a certain font, you could take a font file and you could put it in your app in a certain folder, and it'll like load it in. You can use that in your app. I've never done that, but you could do that if you really want your app to have exactly a certain text appearance. You can download your own font and like pack it into your app if you want. So if you want to use a paint to describe a font, you make a paint and then you tell it to use a certain typeface and a certain text size and then a certain color, and then you can use it to draw text. So I don't like this because to me a paint is like a color. I don't know why a paint has anything to do with a font, but it seems like a paint is like all of the settings for the brush that you're using to draw stuff. So like if you want to write some text on the screen, you can say purple dot typeface equals typeface dot create, and the parameters you usually would use are like typeface dot and then some sort of family like monospace, comma, and then you pass a style like typeface dot bold. So now I've got a font. I haven't told it what size it is yet, so I say purple dot text size equals, I don't know, 50F, and then now here I can say canvas dot draw text, and you say hello CS193A, comma X and Y would be like, I don't know, 400F, and let's use that purple paint, which is increasingly not purple. But, you know, you'll see text up here that has a certain font, a certain size, and stuff like that, I think. So there it is. Hello CS193A, right? Okay. Pretty simple. So, I mean, this thing says, hey, let's make a smiley face. Hooray. I don't really want to make a smiley face. I just don't really feel like it. Also, he's not even smiling. I mean, look at him. He's not very happy. He looks like he's in minute number 79 of one of my lectures, and he's like, when do I get to go? So I think you get the idea. Like, I would make some paints and some colors, and I draw some shapes at some different coordinates. I have a smiley face. I don't think that's the most interesting part of the lecture here. But like, I guess I just want to make sure, like, does this stuff make sense? Like, do you guys have questions about the painting stuff we're doing so far? Yeah.
maybe this kind of goes back to the smiley face, but is there a way we can like compound that so that if we wanted to move it, we wouldn't have to worry about changing all of this?
Right, like what if the smiley face man moves around? Like how do you tell all the shapes to move around? Well, short answer is like no, there's no interesting features here at all. So the idea that the smiley face is a thing that you could move and look at and modify, that is not a concept that's present here. You just issue these very crude drawing commands and then it does them. And it doesn't understand that this oval is connected to that rectangle. It has no notion of that. Like you would have to do that. You'd have to make your own array list and somehow keep track of all the shapes and all the coordinates, and like good luck with that. Like I got something for you, but like Android doesn't got something for you. I do. So yeah, this sucks basically is a short answer. Like there's nothing here. There's no power, no functionality here. You start to see pretty quickly why anybody who was really wanting to do anything complicated would probably get some kind of library or framework like Unity or something. Like this is very primitive, right? It's less primitive. Like you mentioned, is this like the 106 graphics? This is worse than that. So that tells you something right there, right? It's even worse than Stanford's garage programmed dumpy libraries that we have. So yeah, I mean, I could certainly draw this by making a rectangle and a circle and another rectangle, but like, it's not going anywhere, and it doesn't understand any of that at a concept level. I will get to that in a second. I will show you how to do that, but we will have to add something to achieve that. Any other questions still before I move on?
What was that rectf thing in the code?
What's rectf? It's a rectangle class whose coordinates are specified as float. So this is like saying I want a new rectf object. I'm constructing an object there. It wants you to pass the 4 coordinates of the oval as an object. You can not use that. You can just say I only want the 4 coordinates that way. But for some stupid reason, they didn't add that version of the method until a slightly later version of Android. And so if I want to use that function, I have to either modify my project setting to specify a higher minimum version of Android, or I have to wrap this particular line in a version check line, which is, we have not talked very much at all in this class about Android versions. And like, I just didn't want to deal with that because I don't think it's super interesting. It is a thing. If you write a real app that you publish to real people, you sort of have to think about like what version of Android is the lowest one that we're going to support. Google tries to help with this by, generally speaking, not breaking things moving forward. So if it works on an older version, it'll work on a newer version. But when you make a project, you do have to specify like what version of Android that you're going to target. And the default in here is like version 4 point something, which internally is called version 15, I think. So if you look at your little build files, it'll say like minimum whatever version, target version. So these are like the Android versions that you're looking at. And so this thing here that I want to call this like good version of this function that doesn't have that dumb rectf thing, it says that I can't call it unless my minimum version is 21. So like I could go over here and set this to minimum 21, but I think that's like Android 4.4. I don't know. I think if I do this, then that line of code works. I forget. It's like rebuilding or something. Oh, no, that's okay. See, so I don't know, whatever. But the default, if you didn't set that, that wouldn't work without that dumb object thing. So I don't know, whatever. That's what the rectf means. Any other questions so far? I mean, I'm not going to go through all the different kind of shapes and stuff. Like, I just figure if I showed you something and I said, draw this, you just look up the functions you needed to call, right? You get the idea. This isn't probably the most interesting part. So there's another thing I don't want to code with you, which is to draw some targets. There's some kind of loop making ovals and stuff, like whatever. We're going to draw some stuff, but I don't know if that's what I want to draw. So there's other things you could do. You could do images. So if you want to draw an image, you have to put the image in your project, first of all, or download it with Picasso or something. And once you get that image, so the fastest way to get an image is that if you have a resource for it, you can use this class called bitmap factory to read the image in, and now you'll have it as an object type bitmap. Now, this is confusing to some students because you're like, wait, I thought if I wanted an image, I would use an image view or an image button. It's like, okay, yeah, you would, but an image view is basically a view that loads a bitmap and then draws it in its onDraw function. That's basically what an image view is. They like do that for you. But if you have some game and the character is a little image that moves around, like you can't use an image view for that because you're drawing onto your view. And so the way images are represented when you're doing this stuff is you have to make this bitmap object. So I don't know if I have an image in this project. I should have set that up before class. I think I have, like on the slide there's a heart. I think, hang on, let me go see, where would it be? Bouncing ball. Maybe the last time I taught the class I had an image here. No, I don't. Okay, wait, what's what project where I had images? Turtles? TMNT? Let me I just want a picture. I don't know, I don't have an image sitting around. Okay, let's go Donatello, he's the good turtle. So let's do bouncing ball, app, source, main, res, drawable, done. Okay, so I got a picture. If I want to draw Donatello on the screen, I would say something like val don equals bitmap factory dot decode resource r dot drawable dot tmnt done. Don't I have to pass like this or something? What's the I have to pass resources, which is the activities resources object. So right, so I load this bitmap, and then I can say canvas dot draw bitmap, and I pass the bitmap, I pass the xy, so maybe 20 comma f comma 450 f, and then I'm supposed to pass a paint, but you don't use any paint to paint images, so I'll just say null for that. So I think that'll work. It's mad at me again because every single time it redraws a screen, it's going to reload that whole image, which is bad, so I should probably save that as a private var or something. Like, you know, I can fix that. It's not going to really harm anything right now, but that's why that's yellow. It wants me to only decode the image once to save memory. Still working. So you can draw pictures. I mean, most games have some kind of images that are moving around, so I wanted to show you how to make an image appear on the screen. There. So I have a Donatello on the screen. If I don't want him to be that size, I think there's some methods here. I don't know how much of it's on the slides, but I think you could say don.re or maybe it's in the bitmap factory. Sorry, I should look. It's probably on my next slide. Bitmap factory dot what's the wait, do I have it on my slide? Create, it says create scaled bitmap. That's what it is. It's bitmap dot create scaled bitmap. You pass in the bitmap object and the new width and the height, and it'll size it there for you. So like whatever, you can make the Donatello a little bit smaller if you want. You know, like if I didn't like him taking the whole screen up like that, I could say Don equals bitmap dot create scaled bitmap from himself, size 200 by 200. I think. Wait, do I need another parameter? Why doesn't it like that? Do I need to pass some kind of null or something? No? Wait, I'm missing a filter parameter. Boolean filter. Okay, filter false. I don't know. And then if I call that on Don, I think now Donatello is going to be smaller because I changed his size. So. There he is. So, building blocks here, right? Okay, that's bitmaps, and if you want to learn more of the methods and stuff, you can look in the documentation. I want to talk about animation for a second. Oh, why did that image not load up? That's weird. It wants me to log in. Great. Wait. Sorry, guys. I swear I prepare for class. There, see? There's animation. So most of the time when you have a game, you're going to want to animate stuff. And we're not really making much of a game here so far, but like, how do you do animation? Well, in theory, what you're doing is you're periodically telling the screen to redraw itself. And then as you redraw the screen, you move the position of various shapes, you know? So like here would be, let me show you like a little example. So if I have this oval here, right? Maybe it's a bouncing ball, or it's a ball that moves along on the screen, okay? Well, if I want that ball to move, basically I just have to not always draw it at these coordinates, right? I have to draw it at different coordinates at different times. So maybe you make some sort of ball X, ball Y, and you have some kind of delta X, delta Y, that's like where it's going to go or something, like the velocity vector, I guess. So you would say like ball X, ball Y, and the right and bottom, you'd say, well, ball X plus, you know, like it has a size or something, so that's like the size. So maybe the size here is 100, we can make it like 200. So maybe I'd say ball X plus size, and then here I'd say ball Y plus size. The reason you're doing plus is because you're not passing X, Y, width, height, you're passing X1, Y1, X2, Y2, you're passing the corner points, whatever. So you draw the ball at a given position, and then you change the position and you tell it to redraw again later, right? So like how would I do that? Well, what if I made a method called fun move, and this function, every time it got called, it would move the ball a little bit. So you know I have a ball X and Y, and I have a delta X and a delta Y, so maybe I would just like use these to modify those, you know, so I would say like ball X plus equals dx, ball Y plus equals dy. So in theory, if I like called those and then I told the screen to redraw itself, I would animate. So, but then some of the pieces get confusing, like where do I call that from? Who calls that? When do they call that? Animation is typically automatic. Every this many milliseconds, update stuff and redraw the screen. Update stuff and redraw the screen, right? That's how animation basically works. If you want to redraw the screen, there's not like a redraw method. The method for that is called post invalidate. What? I think I have a slide on it. Yeah, so the idea is that Android, I don't honestly totally understand this, but Android has some internal notion of whether something on the screen is valid or invalid. And valid means like I am showing the correct current state of this thing. And invalid means like I'm showing a red circle, but really I should be showing a purple rectangle. What's showing is out of date right now. And if Android thinks that the state of the thing is out of date, it sort of schedules pretty soon I need to redraw this to see the new state. So anyway, when you say post invalidate, you're requesting for Android to pretty soon call onDraw again on this so that the thing will draw itself new state. So I guess really the question is then who calls this? I could call it here at the end of onDraw. I could say after I'm done drawing, move myself and redraw myself, but that would spiral you into this like really tight infinite loop, and you don't really want to do that. So let me just show you a little bit different way of thinking of it. So I have an activity called ball activity, and I showed you the XML for it, where mostly all it has in it is this view, but I do have an OK button, right? So what if this button, what if it had an on-click handler? This is just to help understand concept. What if I call this OK click? So now in the ball activity, which doesn't have any code in it really, I write a fun OK click that takes a view : view. And here, what I'm going to do is I'm going to call that move function on the view. So the view itself is called ball view. So what if I just say, where am I? If I just say ball view dot move, just calling that method that we wrote, okay? So now, if I did that right, every time I click that button, it should move the oval just a little bit, I hope. Let's try. Right? So this is like one frame of animation. Now, this may not match your mental model. Like when I said move, I changed these and I say invalidate, which causes it to pretty soon go all the way up here and call this again. I think the idea is like you were saying, Trip, like, well, how do I like move the smiley face around or whatever? And I think the idea is like you don't move anything around. you're thinking of it as being a thing that has a state that you could modify. That's not how this works. It's like, you tell me how to draw the screen and I'll draw it. And if you want to draw something different later, you can ask me to redraw the screen and then redraw the new thing you want. So if you want to show a ball moving, you got to draw a ball here, and then later you got to draw a ball here, and then later you got to draw a ball here, and like you need to like make that happen by what your code is doing in this onDraw function. So I think of it more as you don't tell the ball to move per se. You just redraw the entire screen with the ball telling itself to paint itself in a new place, and that will look different to the person looking at the screen. So I don't know if I'm making any sense, but like you have to do it in this way to get this to work out. Now, I still don't have actual animation because sitting here frantically clicking on this button is not how games work. So it seems like what I really want is some sort of like, do this a lot, do that more and more, and then I'll have animation, right? So you could imagine some sort of code that says like, while true, call the ball move function. That's not quite right. That's sort of on the right track, but the problem with that is there's no delay, so it'll move the ball a zillion times and it won't be seen because it'll happen so fast. You sort of want to draw it and then pause and then draw it and then pause, right? So, okay, fine. And how do you pause? Well, there is a method in Java and Kotlin called thread.sleep, and you pass in a number of milliseconds, and this is a pausing function. Just wait for this amount of time. Maybe if I pause for 50 milliseconds, that turns out to 20 frames per second, right, just by the math. So now I'll see the ball sort of moving. This also does not quite work because of something called threading. So like, I have a slide on this, don't I? So yeah, this has to do with threads. So why can't I click on this? There. So you guys heard of threads before? Like threads are used for one program to do more than one thing at a time. They're sort of branches of execution where a program can be doing this and it can be doing that both at the same time using this concept called threads. Threads are distinct from the notion of different processes on a computer. Like if you take 107, 110, kind of a systems course like that, you might learn about that distinction. Like two processes means two totally separate programs. You have your music player program, you have your web browser program, you have a game or a chat program, and those are all separate from each other. Those are separate processes. Threads are like within the same program, you've got two little tasks running within that one program. And there's lots of interesting implications of that distinction, but I don't really want to spend a lot of time on that. But the point I'm making is that Android apps that are running, they have one particular thread of code that is used to handle events like clicks. That same thread is also used to handle painting and drawing. So if I have code here that's handling a click that starts what seems to be an infinite loop, that will permanently block my app from ever hearing any clicks ever again. Like the moment someone clicks that button, no clicks will ever be heard in the lifetime of my app. And what's more, the drawing also occurs on the same thread of execution as the clicking, and so I won't even see the screen redraw because it'll be stuck waiting for that, which never finishes. So long story short, if I want to do something like this for animation, I need to create a new thread of execution and tell it to do that part in that thread off on the side. So the way that you make a thread in Android, in Kotlin, is you say val t equals thread, and then in brackets you write the code that that thread is going to execute. So this is code that's going to run off on the side somewhere. And the code I want to run is this code. So in fact, sometimes you even make a function for that, like fun animation loop. And then you paste that there, maybe it's a private fun. And you say, hey, in a thread I want to run animation loop. So creating a thread, you then have to say, hey thread, start yourself. Now, kind of off in the background, it's going to be doing that loop. And my app will not be like frozen up the way I was concerned about a second ago. So that is how to do a very simple notion of animation. If I click this, if I did it right, the ball will just start kind of moving. Let's see. Hey, pretty cool, huh? And it's gone. But I just wanted to kind of get the ball rolling here. no. Even as a dad, I can't really tolerate that joke. Do you understand? Like, maybe it doesn't make sense what I said. Like, if you don't use a thread, like if I just say animation loop, right? If I just do that, what's wrong with that? Let's try it. We don't need this thread stuff. Marty's full of crap. He's wrong. It doesn't seem to be doing anything. What I'll tell you is it is running that while loop. It is updating the ball coordinates. It is pausing for 50 like it's doing all that stuff. It's just that in order for you to see it, it has to redraw the screen, and the redrawing is in the same thread as my code, and so they're both just waiting for each other, and so it never gets to do it. It just, the redrawing is blocked by me. That's why I need that thread stuff in order for that to work. Okay? Right now, you're probably feeling kind of the way that I felt in roughly 1999. I was one of those nerd boys who went into computer science because I thought I was going to make video games for a living. Like I really wanted to make, Mario or something, right? And then when I started to see how fucking hard it was to make video games, I got really depressed. And I was like, man, even to make a ball move, it's just like a whole bunch of stuff, and this is not good. I thought Mario would be like the second course. The first course would be like fundamentals. Course number 2 would be Mario. Course number 3 would be Call of Duty. And course number 4 is I start my own gaming startup, right? That's what computer science is, right? Wrong. It's a lot of work just to get simple kind of graphical stuff going on the computer, right? You have to think about a lot of different things. But that's kind of the basics of, if you didn't want your animation loop to be delayed and wait for a button click like this, you could put this highlighted piece of code up here in onCreate. Like when the thing pops up, start the animation right away. You don't have to wait for an OK click if you don't want to. I just did that to try to prove some of these points here, Questions so far about the thread part?
Yeah. How do you if let's say you press OK and it starts moving, how do you make it stop by pressing OK?
How do you make it stop? Well, so if you save this t as a variable, you can say t.stop elsewhere in the code. Or if this animation loop somehow, if its while loop breaks out, it would stop. So you might have some Boolean flag that you set to false, and then the loop terminates itself naturally. That will cause the thread to stop. So, yeah, good question, because you don't want the app to keep running. This also plays into like the activity life cycle on pause, on resume. Maybe on pause, I want to pause my thread. Maybe on resume, I want to restart my thread. These things kind of connect to each other. Your game shouldn't be animating bouncing balls after the user has exited that app, right? Probably. Any other questions so far about like animation 3D, or not 3D, we're not doing 3D, but any of the threading animation stuff? Okay. Well, so let's make it have a bouncing ball. It moves, it doesn't bounce. So I just want it to be where it hits the edge of the screen, it'll go back the other way. It's a pretty common, like if you're teaching graphics and animation, this is a pretty standard like first exercise kind of thing. 106A, I think they do a demo like this. How would I make the ball bounce when it hits the edge of the screen? Yeah.
Change the X or Y direction?
Yeah, I've got those variables for a dx, a dy, a change in x, change in y. So basically just if I hit the edge, flip them around, right? So when I do this move thing here on the ball view, I could say something like, if the ball x, remember the ball x is the left edge. I want to know if the right part of the ball has exceeded the screen. So like if the ball x plus the size, that's the right edge of the ball. If that has hit the edge of the screen, I should bounce back, right? So the edge of the screen, like a view has a get width and get height, or you can just say width and height. So if I get there, I'm at the edge, right? Or if the ball's left side has hit the left edge, if it's less than or equal to 0, then I want to horizontally bounce. So like dx equals negative dx, right? And then a similar thing if the ball y plus the size has exceeded the height, or the ball y is less than 0, then dy equals negative dy. Oops, I wanted to put this up here, right? We might have a bouncing ball. It's not that much code. I like putting this all in the move. There's like a method that like updates everything. Update all the stuff, redraw the screen, update all the stuff, redraw the screen. See what it does. Yes, awesome. Very slow moving pink ball. Boing. See, and it bounces on the edge of the view. It doesn't go all the way to the bottom of the whole screen. It goes to the bottom of the height of that view itself, right? Okay. Great. Fine. So now my takeaway here is I think all this stuff sucks. I just spent a while teaching you all of it, but I don't like any of it. I think it's very minimal and it doesn't provide a lot of features. So right away I want something better or something bigger, something more. And the last few times I taught the course, I looked, we've done libraries, right? So this is the part where I'd say, let's use the cool game library and this will be a lot better. And what I have found is there's no like medium, just right bowl of porridge here. It's either you do this, which is too, I don't know, cold or whatever, or you go Unity that's like way too big and too much. And I don't want quite all of that bulk and power. I want sort of a simpler little graphics library that just does this a little easier. And there isn't a lot of that, at least not that I found. So what's a boy to do? I made one. I have a library that I wrote, and I'm going to show you a little bit about it. Now, if you don't like my library, you are not required to care about my library, but you certainly are allowed to use it. It's free of charge. It's called the Stanford Android Library. And what I've done here, and I'll show you in the next few slides, is I have recreated the libraries that are used in the 106 courses. They have some little shaped classes and objects called like G-oval and G-line and some other stuff. And a lot of Stanford students have seen those and they know how they work. And they seem to be sort of useful thingies. And I thought it would be useful to have access to something like that here. Rather than make up my own library from scratch that I have to teach you all how I designed it, I thought I would try to match something that some of you would have seen before. So, okay, my library, you know how when we normally want to add a library to a project, you go to your build file and you say you want to add this library there and it'll auto download it for you? Well, that's great and all, but that's for like legit libraries made by real people. I am not in that repository of real libraries. My library is just like a file, and you got to download it and you got to put it in your project manually. It's not very hard once you've done it a couple of times, but here's what you need to do. You need to go to this website, or if you don't know how to find that website, if you go to the top of our class website, there's a link that says library that I never talked about until now that takes you to here, and there's this file called stanfordandroidlib.jar, and you want to save it to your project. The project I'm working on today is called Bouncing Ball. There's a folder in here called app libs. No, this is not a political folder. You save it into that folder, and then once you've done that, you go back to your project and you browse through in your little view of all your files, and you find this file and you right click it and you say add as library, and that's all you got to do. It's actually not very hard to add this if you want to use it. So then once you've done that, you now have access to some new stuff that I have coded for you. So here's what we got for you. Instead of extending canvas, or instead of extending view, you can extend something called gcanvas. A gcanvas is basically a view, except it's a little bit more of an object-oriented paradigm. Instead of saying draw oval or fill rectangle, you'll make these g-oval and g-rectangle objects, and you can tell the canvas that you want to add those objects to it. And it'll remember them and it'll draw them. But what's better about that is you can then talk to those objects and say, hey, move yourself. And then it will automatically move it and redraw it for you. And like if you want to make a smiley face that moves around or something, it's a little easier to manage, I think, this way. So let me show you kind of how this would work. So instead of the bouncing ball view that I have here, I could make a bouncing ball canvas. Wait, I want to be in Android mode. a bouncing ball canvas. A bouncing ball canvas, you have this kind of same heading, except instead of extending view, you extend G canvas. Now you initialize your shapes here, and then the thing will just draw itself for you. You don't actually need to override the onDraw method because my gcanvas does onDraw. So you could do something like the following. If you have a bouncing ball, which is, this big with this velocity or whatever, you kind of don't need as many variables. So you could do something like, private var ball equals a g-oval. So a g-oval, you could say the g-oval is, size by size or something. Or you could say it's at a given xy position at a certain size, I guess in float. And then when you're initializing your canvas, you just add the shapes that you want to see on the screen. So you could just say like add ball. And now the ball is there. And if you want to, see the see the ball move, then it's easier to do that. Remember how we had a function called move? You could just say ball dot move by, how much do you want to move by? Dx, dy. And then by moving it, it should automatically tell the screen to redraw itself, so you don't have to think about some of that other stuff. The other thing is, thread crap and redrawing and post invalidate and kind of all that stuff. You don't necessarily need to do that. The thread you can just do by saying I want to animate certain number of frames per second, like I want 60 frames a second, and it'll just like redraw the screen for you. So it's like meant to be a little bit easier. It's meant to be more similar to the 106 kind of libraries. This documentation for this stuff is on the webpage that contains the library if you want to look at it. The only other thing you would need to do is here you would need to say this is not a bouncing ball view, this is a bouncing ball canvas. So I'm going to use that other class instead, right? Okay, so now I'm not quite done. Like I haven't done the bouncing, like if it hits the edge, then you got to turn around or whatever. But I could kind of mostly steal that from here. I can say if x, y are out of bounds, but I don't say ball x. I would say ball dot x because the ball is an object and it has an x and a y position. But you don't have to say ball x plus size. You can say ball dot right x. So that's like the x of the right side. So it just like knows how to calculate that for you. Or ball dot left x. You know what I mean? Like basically similar code you can put here. So this is ball dot right y, not right y. It's the bottom y, like that. Okay. There. So I guess let's convince ourselves that it's going to work. One thing I haven't done here is I haven't set the color. So you could say, you could make a new paint, like we had the purple paint here where we said, where is it? Purple set RGB, you could say val purple equals paint and purple set RGB. I got to import paint. And then I could say ball dot set fill color to be purple. So again, like a lot of these method names, like I have to admit, the people who like this library the most are the 106A section leaders because they're like, oh, I help my students, and that's what the name of the method is in my office hours, and so it's the same. They call it set fill color there, and they call it set fill color here, so that's nice to have that consistency. Or I think some of these methods you can also just say fill color equals purple because Kotlin has kind of a property syntax like that. The other thing you could do is if you don't want to write out several lines to pick a color of something, you can just say like G color dot, and then there's a bunch of colors like, green or something, and so you can set the color to an existing color. Just save you a little bit of code. So let's see if this works with a bouncing ball canvas instead of a bouncing ball view. So there it goes. But the thing that I forgot is I didn't think I would need to click that because I told it to animate itself here. But what I forgot to do is if you say animate 60, you have to tell it like what do you want to do every single time each of the 60 updates per second. So you can put curly braces and then write the code you want it to run. So like what I want it to do 60 times a second is move. I want it to call that method 60 times a second. So now I think I'm going to rerun the program and I won't have to click the OK button. It'll just start animating. And then, of course, what's going on inside of here is it's creating a new thread. It's doing some of the same stuff I was teaching you a few minutes ago, right? Now, you might say, well, I don't know. I'm not so sure if this thing is any better, but I think where it becomes more useful is like if you have a lot of shapes. So I thought maybe we could do one, I used to live in Seattle, it rained a lot in Seattle. Maybe we could make it so there's like some raindrops that fall down from the top of the screen. And I think what would happen would be the more raindrops we had, the more of a pain in the ass it would be to keep track of that using the real stuff, and the less painful it would be with this library stuff. So let me ask you this, how would I make raindrops that appear at the top and then sort of fall? I could try to help you frame this a little bit. Like, if I talk about raindrops, plural, a way to simplify this would be, could I make a raindrop singular? Could we just write a piece of code that would create a raindrop and put it onto the screen? So what if I wrote a function called like fun make raindrop, and it will, add a new raindrop to screen to the top of the screen at a random x coordinate or something. You understand? So like, how would I, what are some things I could do to help me make a raindrop? What sort of object is the raindrop going to be? Okay, so like val drop equals a g oval. You're supposed to pass x, y, width, and height. So if you don't pass them, you'll get zeros. We probably don't want that. So maybe up here, I could make like private val raindrop size equals, I don't know, 10. That's the width and the height of a raindrop. So maybe here, I want to write some sort of x, some sort of y, size. What are the x and the y's that the raindrop should be at? What y coordinate does the raindrop start at? 0. It's at the top, right? Okay, what x should it be at? Random? Okay, so like a random number generator next int, something like that. Next int from 0 up to what? Width? Yeah, maybe width minus raindrop size, like so that it doesn't fall mostly off the screen. I think this would be a float. Wait. Oh, this needs to be an int. This dot to int. The random number generator. What did I do? I think I imported the wrong random. It's java.util.random. Okay, so val x and val y. Since Android is kind of stupid, it doesn't like ints, it wants floats. So I'll say dot to float, y dot to float. Okay, everyone floats here. What did I say that wrong? What's the quote? Never mind. So I made a raindrop. If you create a raindrop, it does not put it on the screen yet. So if I just create one, I don't see it yet. I need to do one more thing, right? What's that? I need to add it, like put it on the canvas, right? Okay, cool. Now the raindrops are supposed to like fall, right? So I guess there's a couple things missing. Like I don't have a plural. I'm not like calling this method from anywhere. So I need to call it preferably multiple times so I'll start getting lots of raindrops. And I need them to fall, right? So I guess we could tackle the plural part first. Maybe like once per second, we could add a raindrop to the screen. How do I do something once per second? How do I know when a second has passed? This is a deep existential question, right? What does time mean? Is time real? I mean, this is not like a secret here. I'm just trying to think, like, how would I represent this concept in my code here? This is just stuff, just programming stuff. Yeah, what would you
Do
do?
you 1 FPS?
Oh, so, okay, you might say do another animate with 1 FPS. Yeah, I don't know. I don't know if you can do 2 calls of animate. I think the second one would override the first one.
Okay.
So I think what I would have to do is like this. I know this is going to happen 60 times a second. So I should extrapolate from that to figure out when it's something happening 1 time per second, you know? Like, any ideas?
So every 61 of those, we call that.
Yeah, like every 60 times move gets called, I should add a raindrop. So one thing I could do is I could keep a like private var of a counter. Every time I call move, I plus my counter. When it gets to 60, I could add a raindrop, right? I think that would be fine. I'm trying to remember. I think there's like a animate frame. I thought there was like a frame count. Get frame. Maybe not. Maybe I took that away. Okay, so that's fine. So just up here, private var ticks equals 0 or something, and then every time you move, I'll say like ticks plus, and then if ticks is 60, or how many is it, 60 frames per second? Maybe I should make a constant for that. Whatever. If it's 60, then add rain. What did I call it? Make raindrop. Make a raindrop. Sorry. Make raindrop, and then ticks goes back to 0 or something. I don't know, whatever. Right. So add a raindrop. So I think I could test this already, and what I believe will happen is that raindrops will gather along the top of the screen and they will not fall, right? But look, I claim still, even if that's all I have, I'm still doing better. Do you see them? They're small. Maybe I should make them bigger, but like I think it's working. If you don't have sharp eyes, you may be able to see this. But what was the raindrop size? 10? Maybe more like 40 or something. Probably the raindrop, I should probably say something like drop.set, like fill color equals gcolor.gray or something. Don't I have a gray? Gray? I don't know, whatever. Okay, raindrops are happening. They aren't moving. But I would still say that I'm already winning a little bit by using this library, because keeping track of all these raindrops, I'd have to keep some sort of like giant list of I don't know what to remember all of them and where they are so that I could draw them all in the onDraw function. You know what I mean? Like that's all just kind of happening for me here. Okay. How do I make the raindrops fall? How do I make them fall? Any ideas?
Animate them.
I could animate them. Well, I have an animate command already. The one thing I'm kind of hearing from you guys, like, it seems like you want to sort of start another animate call to do another animation action, but I think like whatever's in here has to do all your stuff. You can't do another animate. You know what I mean? Like it only does one of these. So, like, I think we need to like put some more code in here or something. You know, or maybe if it makes more sense, I could do something like move ball. That's what this function is for. And maybe there's a separate function called like update raindrops, and the update raindrops will move all the raindrops down a little bit. So the update raindrops would be, maybe I'd grab this here as well. You know, if I need to make a new raindrop, I'll add one. But it seems like here, like if I want all these guys to, look at all these poor things. If I want all these guys to be falling, I need to like set their position, their y coordinate to a different coordinate, right? So I guess I need to think of like what's the falling velocity of these. Maybe I'll make a constant up here called like private val raindrop dy, delta y. They fall by, I don't know, 6. That might be too much. Maybe like 4. I don't know what. Some sort of change of pixels of y every time I repaint the screen, you know? So basically for each raindrop, I want it to move down by that much, right? Yeah, question?
Can you loop over the raindrops?
Right, so basically I just want to say for each raindrop, move down by that much, right? So there's a couple different ways you could do it. If you don't know any other stuff other than what we've learned so far, you could just save some collection of all the raindrops. You could save an array list of them or something, and when you move them, you loop over that array list, right? That would be fine. Another thing you can do, let me see if I have the, here is the set of methods that the canvas has. You can ask for each of the elements in the canvas if you want to. You can loop over them all. And you could move them all. The only downside I can think of with that is that that would also return the ball, the red ball that's bouncing around, and I kind of don't want him to be moving. So, like, but I think we can get around that problem. So something like this. Let's see, so if I say this dot element, there's like element count, get element at, right? So you could say something like for I in 0 until element count, you could say val shape equals get element I. So it's just like loop over all the shapes in this canvas by an index, you know? I think, I might be wrong about this. I thought I coded this so you could say for shape in this. Does that work? Yeah, that's the same. So that's easier, right? That's the same thing. Just loop over all the shapes in this canvas. So for each of those shapes, I could say shape dot move by no x, but that much on the y, right? That has the problem of it will also match the bouncing ball, right? So how do I not do the bouncing ball? You have an answer?
You could just, when you move the bouncing ball, you could move it by minus raindrop.
Oh, yeah, so I could just say ball dot move it back, move it by 0f negative. Yeah, that's true. You could do that. That totally would work, except you might see just the teensiest little flicker of that. So I guess I was just sort of thinking like, if shape isn't the ball, you know, like whatever, right? Or I mean, again, you could have saved an array list of all the raindrops. That would be fine too. But this maybe doesn't require that. So this is to make the raindrops fall. Let's try it. Oh, do I have an error? It says error unresolved. What? Let me try again. Compilation error. I renamed this method, and then in the activity, it's trying to call it. It's a move ball. Yeah. Okay. Sorry about that. Let's try again. You ready? Cool, huh? Bouncing ball with raindrops for some reason. I don't know why we have both of those things on the screen at the same time. So anyway, I'm basically done. But like the reason we're doing this, again, if you don't want to use this library, you don't have to. But I just wanted something simple, and I think the idea here, I'm sensitive to the notion that I mostly want to teach you guys real Android, I don't want to teach you a bunch of goofy, weird custom stuff that only works at Stanford, and then you go do Android code somewhere else, and they're like, what is this? You're coding the wrong way, or what? I don't want you to be taught the wrong stuff. I showed you how to do it the real way. My libraries are just built on that. If you want to see how they work, you can go look at their source code. I basically just have my own class called gcanvas with an onDraw method. It has some array list of shapes in there, and when you say add, I put your shape in my array list. And in my onDraw code, I loop over that array list and I draw all the shapes. And so I'm just providing a little bit on top of that sort of crappy Android drawing, setup that comes with Android. And my intention was to do something not very fancy because I didn't want to make you feel like the library was doing magic or something. And so you saw how to do the thread, and you saw how to draw shapes, and you saw how to move shapes, and that's basically all this is doing. So you can use it or you cannot use it if you want, but if you don't use it, you have to keep track of all the shapes and all the positions and all the colors, and you could set every raindrop to be a different color, and you have to keep track of that. And so it's just like whether you want to keep track of that or whether you want my little library objects to help you keep track of that. It's your decision. And what we're going to do with this on next Tuesday is we are going to actually try to make something that's more of a game that has different things that like collide with each other, and points and scoring and control. You press the key and it moves the character, and like a little more of an actual interactive game. Pretty crappy, but an actual game experience to kind of see how you would build that. So that's what we're doing. So anyway, I'm done. And any last questions before we go?
We've been doing everything in pixels. Is there any way to do anything like in a more relative way, like relative to the actual layout?
So if you wanted to be more of a percent, you'd say like width divided by whatever, or height divided by, like there's no native understanding of percent in the library, but you can ask the view for its width and height, and everything is relative to that if you want it to be. We didn't really do that in the code, other than the bouncing uses the width and the height, but you certainly could, yeah. Any other questions? Yeah.
Similar to that, so that works when you're creating all the objects, but if you wanted the heights to be percentages when you're putting them in the like XML and the view, like you want that ball to take up half a screen and that data to take up half a screen, is there any way to do that?
Well, that's more in the XML layout. You can specify, like if you constrain things to each other, they tend to split the space. Also, if you have some of the linear layouts and stuff, you can say weights. You can specify weight of 1, weight of 2, and that can be another way to evenly distribute pixels in percentage forms. So yeah. So that you would do that more in the layout XML and not in the Kotlin code. Okay, well, I'll post this code on the website. Guys, have a great weekend, and I'll see you next Tuesday. Thanks.